Welcome to this Cognizant Data Scientist interview preparation session. In this video, you will get 5 real interview questions with structured answer strategies. Follow the interviewer prompts and structure your response for strong selection outcomes.
Can you explain how you would build a sentiment analysis model for customer reviews leveraging BERT? Walk me through your approach.
To build a sentiment analysis model using BERT, I would start by fine-tuning a pre-trained BERT model on a dataset of labeled customer reviews. This allows BERT to leverage contextual embeddings and improve classification accuracy. The trade-off is BERT's higher computational cost compared to simpler models, but the accuracy gain justifies it. For edge cases like sarcastic or ambiguous reviews, I would incorporate domain-specific vocabulary and use data augmentation techniques to improve robustness. Finally, I would validate the model using metrics such as F1 score and seek user feedback to ensure practical effectiveness.
Can you walk me through how you would select the most appropriate machine learning algorithm for a new business problem?
To identify the right algorithm, I start by understanding the problem type, whether it's classification, regression, or clustering, and the nature of the data available. Next, I shortlist algorithms that best fit the data size, feature types, and business goals, considering factors like model complexity and interpretability. I weigh trade-offs such as accuracy versus explainability to align with stakeholder needs. I also consider edge cases, such as class imbalance or missing data. Finally, I validate my selection using cross-validation or a pilot test before deployment.
Can you explain the difference between k-means and DBSKN clustering algorithms? And in what scenarios would DBSKN be the preferred choice?
K-means clustering works by assigning data points to K clusters based on proximity to centroids, assuming clusters are spherical and similarly sized. DBSCAN, on the other hand, groups data by density, identifying dense regions as clusters and labeling sparse points as noise. I prefer DBSCAN when dealing with data that has irregular cluster shapes or noise since it can handle these scenarios better. A trade-off is DBSCAN's sensitivity to parameter choices and difficulty with varying density clusters. Nonetheless, its noise handling and flexibility make it great for spatial data and anomaly detection scenarios.
Can you explain how you would quantify the business impact of improving model accuracy by 2%? How do you approach this analysis?
To quantify a 2% increase in model accuracy, I first identify the key business metrics affected by model predictions, such as revenue, cost, or customer satisfaction. Next, I estimate how the improved accuracy translates into better decisions. For example, reduced false positives or improved targeting, which impact these KPIs. It is important to consider trade-offs, like increased model complexity or latency, which can offset benefits. I also evaluate edge cases such as data shifts or rare events to ensure robustness. This holistic approach supports clear business communication and iterative model improvement.
Can you explain how you apply residual analysis to understand and diagnose prediction errors in your models?
Residual analysis is crucial for diagnosing model prediction errors by comparing the difference between actual and predicted values. Typically, I plot residuals to identify any patterns or systematic deviations which suggest issues like bias or heteroscedasticity. This method reveals where the model struggles but can sometimes be misleading if the underlying data is nonlinear or heterogeneous. In such cases, I explore feature engineering or different models. Overall, residual analysis guides iterative model refinement and validation.
This completes your Cognizant Data Scientist interview preparation set. Practice these answers aloud, refine clarity, and repeat daily for stronger interview performance.